Hi guys, it's time for another lesson. Today we're going to be talking about simplifying inequalities. So when we simplify an inequality, we're not going to be able to solve for an exact answer for our variable, which is why we call it simplifying instead of finding the solution or solving. Our variables are going to have multiple possible answers when we are working with inequalities because it could be greater than or equal to, less than or equal to, just greater than, just less than. So we have different possibilities for our variables, but simplifying helps us determine what our variable could be. So get ready to take some notes and learn more about inequalities.
Okay, so today we're going to be talking about solving inequalities, or as I like to say, simplifying inequalities, since our inequalities will not necessarily have one answer for the variable. So inequalities, those are two numbers or expressions that are not equal. So we have four different symbols when we're working with inequalities. We have the less than symbol, the less than or equal to symbol, which is basically just the less than symbol with half of an equal sign underneath it. Then we have the greater than symbol and the greater than or equal to symbol, again with half of an equal sign underneath the greater than. When we're solving inequalities, we're going to be doing the exact same steps or process that we use to solving equations. What you do on one side has to be done on the other side. Now, what's important to know about inequalities is there will be an infinite set of solutions. So that's why I like to often say we're simplifying the inequalities, because we're not going to find one solution. We're really going to be finding an infinite number of solutions. So today we're going to do 4 practice problems simplifying, and then we're going to do a practice problem where we're substituting numbers for the variable to see if the equation is true. So get ready to take some notes and solve inequalities. Our first practice problem is x plus 3 is greater than 12. This is a one-step problem, so we only have to do one thing in order to figure out what x could be. Now, if I want to get x by itself, what do I need to do? Hopefully you remembered the inverse of addition is subtraction, so what we need to do is subtract 3 from the left side of the equation. You'll often hear this called as zeroing out the constant, which means that constant on the left side is now 0, and x plus 0 is just the same thing as x. Remember, what we do to the left side, we also have to do to the right side. So once we do the same thing to the right side, we have 12 minus 3, which equals 9. And the last step is to rewrite your inequality. I'm going to keep my x lined up, I'm going to keep my greater than symbol lined up, and I'm going to bring down the right side of the equation so I can see that x is greater than 9, which means x can be any number bigger than 9 to make this equation true. Now it is not greater than or equal to, so it cannot equal 9, but it could be 9.1 or 9.0001 or any infinite amount of numbers bigger than the number 9. Our next practice problem is 2y plus 13 is less than or equal to 33. So this one is a less than or equal to. And now this is going to be a 2-step problem. I want to start by zeroing out the constant. So go ahead and pause the video to zero out the constant. In this equation, we had another addition, which means the inverse is going to be subtraction. So 13 minus 13 equals 0. If I do that to the left, I've got to do it to the right. When you went and subtracted 13 on the right, hopefully you saw that 33 minus 13 equals 20. Once I've rewritten my equation, I should have 2y is less than or equal to 20. Now 2y is actually a multiplication problem, and the inverse of multiplication is, hopefully you said division. So now I need to divide each side by 2. It's important to remember we can write it as a fraction because fractions represent division. So if I write 2y over 2, the 2's cancel out, and now I'm left with just y. and that's going to be less than or equal to 20 over 2. So what is 20 over 2 equal to? Hopefully you said that y is less than or equal to 10. So it could be 10, it could be 9.99999, it could be 8, it could be 7.5. Y could be anything that is less than or equal to 10. Remember, it has an infinite number of solutions. Okay, our third practice problem is 5 plus 2y is greater than or equal to 7. Now I want you to go ahead and zero out your constants. Now, we didn't see a symbol in front of the 5, which means we can go ahead and assume it's positive since it didn't have a negative sign in front of it. So positive 5 minus 5 equals 0, which means 7 minus 5 needs to equal 2. My new equation should read 2y is greater than or equal to 2. So again, now we need to get the variable alone, and we need to remove that coefficient. This is 2y, which means it's multiplication. The inverse must be division. If I do 2y divided by 2, all that's left is the y, and that's going to be greater than or equal to 2 over 2, because fractions represent division. So what is y equal to, or what could y be equal to? Y can be greater than or equal to the number 1. So it could be 1 or it could be 1,000,000. Y could be any number bigger than 1 or equal to 1. Our fourth practice problem, I'm going to throw in a little fraction here. So we have b over 5 plus 20 is greater than or equal to 75. Go ahead and cancel out or zero out your constants and rewrite your new equation before continuing on with the video. Your new equation should read b over 5 is greater than or equal to 55. So now we're at kind of a tricky spot. We have b over 5. What did I say fractions represent? Now I'm hoping and praying you guys all remember that fractions represent division. So here I see b divided by 5. And the inverse of division is multiplication, which means we're going to need to multiply each side by 5 in order to get b by itself. So if I do 5 times b over 5, the 5's cancel out and I'm left with b. And then 55 times 5. Now that's a tricky one and I'm going to need to work it out before I know that solution. When I did 55 times 5, I found that b could be greater than or equal to 3,025. So b can be any number equal to that or bigger than that. Now I want us to try solving an inequality problem using substitution. So I've given you 4 different options for this equation, and I want to know which of these options make this inequality true. So the inequality says 10e is greater than 29. So let's fill in e with 2, 9, 1, and 4 to see which of these numbers will make the equation true. Now it's important to remember when we see 2e, that means we're 10e, we're multiplying 10 times e. So if I replace e with a 2, I have 10 times 2, which equals 20. I hope we all can remember from way back in kindergarten that 20 is less than 29, which means that does not make the equation true. We need our left side to be bigger than 29. Now let's try solving if we place a 9 where the e is. 10 times 9 is 90. Now is 90 greater than 29? Give yourself a nice pat on the back if you said 90 is greater than 29. So that means that b, 9, makes the equation true. Now I want to go ahead and double check the last two because there could be more than one correct answer. Let's just see. Now if I do 10 times 1, that's going to equal 10. And I know that 10 is less than 29. If 20 was less than 29, 10 has to be less than 29. So there's only one more answer choice to check. If I replace e with a 4, I have 10 times 4 and I get 40. So 4 also makes the equation true. I want you to try a little bonus. What is the smallest possible whole number e could be? To make this equation true, what is the smallest possible whole number e could be? Pause the video while you're thinking and play it again when you're ready to check your answer. Hopefully you said the smallest whole number e could be is 3, because 10 times 3 equals 30, and that's only 1 away from 29. But is that truly the smallest number e could be? Remember, inequalities have an infinite number of solutions. So what is the smallest number e could be? This is pretty tricky, and you probably don't even have enough space on your paper to write the real answer. Pause the video until you're ready to check your work to see if you got the same thing I did. So I said that e could be about 2.90000000001. Now I could put a million zeros in between that 9 and that 1 to make it even smaller, but I don't have enough space on my paper. So the number just has to be anything bigger than 2.9. It could be 2.91, 2.876543210. Anything bigger than 2.9 would be the smallest or closest number we could get. Because it didn't say equal to, so it can't be 2.9. It has to be just a teeny tiny bit bigger. So that's all we have on inequalities today. Hopefully you guys enjoyed the lesson, and I look forward to seeing how you guys do on the Google form. Show me what you know.